Imagine a bucket full of water. If the bucket is upright, we know the water remains at the bottom of the bucket. We also know that if we were to flip the bucket upside down, the water would fall out. Now picture a bucket of water swinging in a vertical circle. Notice that as this bucket turns upside down, the water remains in the bucket. So why does the water remain in this bucket as it rotates upside down? This is due to the speed of the water bucket being greater than the motion's critical velocity. So velocity is greater than the critical velocity. So critical velocity can be represented by the following equation. So we have VC, which stands for critical velocity, and that's equal to the square root of little g, which we know by now is 9.8, times r, which is the radius of the circular motion that we are representing. And if we determine what the critical velocity is, then we will know the minimum speed, the very minimum speed at which the bucket of water can move to complete the circle without losing any water. Okay, so to calculate the critical velocity, we're going to use the equation that we already determined, which is the square root of little g times r. So little g we already know. It's 9.8 meters per second squared. We really should know that one by now. So really we're determining what r is. And that's a little bit more complex. So the radius is actually made up of the length of my arm to the top of the bucket, as well as the midpoint to the midpoint of the middle of that bucket. So you're going to take r, the radius of the arm, and that's representing the shoulder to the top of the bucket. And that was measured to be 35.5 inches, which converts to 0.917 meters. And then you have the r of the actual bucket. The length of the entire bucket is 15 inches, which converts to 381 meters. And we're going to want to divide that by 2 because we want half of that length. So now we have our two values for r. So what we do is we just add these two together. The 0.917 plus the 0.1905, and we will get 1.0922 meters. And now what you do is you plug in little g times the r that we calculated. And when you get the square root of that, comes out to the critical velocity of 3.27 meters per second. So if the velocity of this motion is less than the critical value for velocity that we calculated, which in this case is 3.27 meters per second, then the normal force on the water as it turns upside down is equal to 0, which results in the water falling out of the bucket.